system that we use has an accuracy of plus or minus 0.4 millimeters.
The 3D printed orthotic is, since the shape is perfect with the foot, the pressure on the foot is very equal. So I don't need to use much top cover anymore.
Hi, it's Phil and Fred. Welcome to Modern Footprint, the podcast that is rethinking podiatry and shaping its future. Hello, everybody. It's a pleasure to be with you again today. We're going to start a new session of our series of podcasts. Today, we'll be talking about our 3D printed orthotics and our 3D scan, where what we did, how we came from conventional orthotics, manual labor to produce it all the way up to now doing 3D printed orthotics and using a 3D scan. We're lucky to have with us our general manager at Cryos Technology, Nick Watts, who's also a biomechanical engineer. And he'll be the one talking to us about, everything we went through from the beginning of our journey to go from, like I said, conventional orthotics to 3D printed orthotics. Phil is also with us again. Phil?
Yeah. Hi, Fred. Yes, so it was a big journey from going to traditional way of making orthotic with all the challenge that we had with the plaster cast or the foam box that was not necessarily as accurate as we think as a clinician it would be. But once it's in the lab, we'll pour plaster, we change the shape of the foot by doing this, and then we heat mold the orthotic, and then we cut it. But at the end of everything, it's not necessarily exactly the patient foot. There's all kind of error that is going to be in the process. So that's why we went with a new technology to remove those errors.
And being clinicians, for us in our clinics, Phil and I, we knew what we wanted to do. But now to be able to do it is another story. So this is where we needed to have people with us to help us. And this is where Nick came, when he started to work with us more than 10 years ago. And this is what we're going to explain to you, what we went from. So, hi, Nick. How are you?
Hey, Fred, Phil. Thanks.
Yeah.
Great to be here. So as you said, I was graduated biomedical engineering, University of Sydney in Australia in 2010 and made my way over to Quebec in Canada. And about 10 and a half years ago, I found Cryos. Cryos found me. And I remember clear as day, I went into the interview. Here's this this orthotic lab in Joliette, and not quite sure what to expect. And as Phil and Fred, as you explained the process to me, I could just start, I could see it lining up in my head what we needed to do. At the time when I went in, as you said, everything was very manual. It was foam boxes and plaster casts and all manual operations, which created at the end a very impressive orthotic. And, it was appreciated by all of our podiatrists, but you could see the human errors adding up in the process. And I think the prescribers at the time, yourself included, you'd learn to live with these errors. Sometimes you'd order an orthotic and the arch would be a little too high. So next time you'd order it a little lower, but then, then it's way too low. And, but you just learn to live with it. There was no other option. But we'd always had, or there was so many more people that wanted the orthotics, but we could not physically make them. The production process being so manual, there was so much labor involved in it that training people to do it was a problem. Not to mention shipping all this stuff around. And it came at a good time when the advancements in 3D printing became much more available. 3D scanning became much more accessible. And so once I started at Cryos, that's where we started at the beginning. It starts at the input. So
and I do remember, we had that conversation with you telling you, all right, we just want this orthotics being printed now. Yeah. Let's go for it. And we had no clue where we're going to go, what to do. And the thing is that for you, it wasn't easy, I think, and which seemed it was working for us in our office. The orthotics were doing great to our patient. They were happy with it. But now we knew we needed to go the next level. And doing that, I knew you had pretty some good idea, but
Yeah.
we told you, all right, but it better work with our patients, so go for it.
And it was, I have to say, a bit daunting at the start. I could see the big picture, but, actually the fine details on all of it was quite a challenge. But starting at the start, we wanted to have a very good input. We knew if we didn't have a good input, there was no hope at the end of it, no matter what we did after it. If we didn't have a good representation of the patient's foot, we were just making stuff up. So we worked together to develop the CryoScan 3D, and something that was missing in the industry at the time, and even when we look around now, is a reliable way to position the foot.
Yeah,
and it's an interesting problem. You want to capture a 3D scan of the patient's foot, but the how do you do that? How do you position it in the right position and still capture that shape the way you want it? The foot is being treated in the shoe. How do you capture that position? You can't stand on a piece of glass and scan that. Everything's flat. You can't use that. Maybe you could take some measurements from it, but you could never create an orthotic from that. And looking at some of the more accepted ways of taking a plaster cast, it involved wrapping the foot in something and holding the foot in a position. So we look to enable that positioning with a 3D scanner. So that's where we had the idea to use a silicon membrane, and we developed the FSS. So the foot suspension system that you see here, and you can take a look on our website and see what that's all about. But the idea was to make a reliable, repeatable way for you guys to position the foot before taking a 3D scan.
Yeah, and we went, and remember, and Phil, if you do remember, we went from plaster casting to foam box, pouring plaster in it, and then having the positive cast and being able to cut the orthotics and mold the orthotics. And we knew we needed to change that in order to keep all the intrinsic value of the orthotics, but at the same time making sure that it works really well with our patients' feet.
Yeah. And so the final iteration of this, the CryoScan 3D, we've got a number of patents around it to protect the different ideas, but it just speaks to the uniqueness of the system that's there today. The key part we wanted to have, though, is an accurate scanner. It does us no good to invest all this effort into having a repeatable positioning if we can't capture that accurately. So we partnered with the gold standard of 3D scanners at the time, with the iCube, and we adapted their system to fit with the FSS, and that's what we have today.
What do you think was the most challenging part for you when we asked you? We remember we went through the iPad, the iPhone, all those technology. What was challenging for you to decide this is what we should be using? Knowing was it, like you said, the accuracy? Was it the space, the speed of the scanner?
Yeah,
was it something that was leading you to where we are now?
I mean, it all comes into it. It's all a big picture, right? I mean, when we started working on this, the iPad type of scanners were still a concept at that time. They weren't quite there, but there was other things around. There were some very, very expensive systems. We played around with creating our own technologies. But as the iPad developed and everything, it sounds like a great idea, right? Here's a device that you can just stick in a drawer. It takes up no space, but it's inherently inaccurate the way it's done. Moving around the foot, the scanner itself, they say on the box, it's plus or minus 4 millimeters. But that's just off one scan. To capture the foot, you've got to go all the way around it. And so the errors start to add up. And, what that was fundamentally opposed to what we wanted to do and have an accurate scan out of the box. But the usability of it as well. I mean, there's so many factors going on in a podiatry office. There's the flow of patients going through. We need a system that's easy to use, easy to install. So it's quite a complex problem to put all together.
And what we wanted from the scan, it's to get something close to what we were used to do, because we knew we were able to position the foot in the right position and have the orthotic that fit correctly. So going from a plaster or foam and with the iPad, it was a lot different. We didn't want to make so much change in the CAD software. So again, it's not the patient's foot. We changed it so much. So like we were saying, we didn't want to have a glass. So we need to imagine what the shape of the foot would be.
Yeah, we don't want to make up data on there, right? When we're making it up, we're guessing, and the point is to remove the guesswork from the lab. We're not seeing the patients. You guys are. So you're the ones making the informed decisions.
So what is the accuracy of the QR scan?
So the system that we use has an accuracy of plus or minus 0.4 millimeters.
Wow.
So that means 0.4 millimeters to the ground truth, as opposed to other systems where plus or minus 4 millimeters.
Okay, so went from 4 to 0.4.
Yeah, so it's a big difference. It's a big difference. And, you think plus or minus 4 mils in the arch, that can have a big impact on the corrective effect of the orthotic.
When we give the orthotic to the patient, sometimes you increase or decrease the arch by 1 millimeter, and it makes the whole difference that patient is able to tolerate it or not. So plus or minus 4, that's a big jump.
And it's important to know that it's the combination of this accurate scanner and the repeatable positioning. And if you can never be repeatable in how you're positioning the foot, you can't have the confidence to know what you're scanning and what you're prescribing.
And how did you came up with a way to be more repeatable within you or with the other podiatrists?
So with the FSS that allows that feedback positioning the foot, where we have the training program when we install the scanner, and we accompany the podiatrist or the chiropodist or the user through the process, and within a short time span, they're up to speed. But something that the innovation we put in there to really accentuate that is the viewfinder camera. So we've placed a camera inside the box that looks along the back of the foot. So you see the heel in the foreground, the forefoot in the background, and it allows you to see the foot in the position you want before you scan it.
And this is, if I just stop you for a second, sorry. This is in podiatry something that we've been taught in school. We've been taught. That's why we went from what used to be the gold standard. With plaster casting, you were able to see the rear foot, the forefoot, and position it in a way that you were able to see the relationship between the rear foot and forefoot. And with the foam, the biofoam, the foam box, we could not see that. And that was always the drawback. And we're saying, it's not as precise. But now, like you say, by being able to incorporate the camera and being able to see the foot, that changed completely, the output, So when we take, our scan, we're able to see where we're going and we can change it. And we're able then after that to make any adjustment we need to make.
How long does it take to do a scan?
We're talking the order of a couple of minutes. The scan itself is seconds, 6 seconds back and forth, and you have the scan. I think between the patient coming in, setting up, sitting down, taking the scans, reviewing them and leaving, we're talking 6 minutes.
Okay.
So it's a very useful technology. And the patient's response is also quite impressive. You sit down, the normal setup, we have the scanner there with a TV in front showing the viewfinder and the 3D scans. And the interaction with the patient is quite important too, to explain to them what you're trying to achieve and how you're trying to correct their pathologies. And it involves the patient in the process.
Yeah. The patient see the scans he see the foot while you positioning it and then you see the scan when it's done. So they're always very impressed.
Yeah, I do invite our listeners, if you guys want to go on our website, we do have a really good video where you see that. You see the foot, the screen, all the process that we make that Nick just explained. Yeah. And that's a big plus for the patient and also for the practitioner, because if you're able to see what you're scanning, then you're able to make the decision you need to make. If you want to adjust it, are you going to post it, all the different prescription that you need to add on your orthotics.
But so do you need to two person to be able to take the scan, or how does it work?
No, so well, that's an interesting point you make there, because you have to position the foot, and that ties up all your hands. So to get around that, we've developed a voice-activated trigger for it. So you sit there and you have your own keyword, OK scan or OK go, or we can customize that for you. And once you say the word, the scan starts itself. So it frees you up to do what you need to do with the patient's foot.
Okay, great.
So it's an interesting discussion we have with new podiatrists, new chiropodists, when we're showing this system around. We have a lot that are very wary of 3D scanning. They might have tried some systems and they don't like it at all. So they just say, 3D scanning is not for me. I like plaster casts and that's it. And we show them the system and they think about it and they say, hey, hang on, there's something to this. This is much more in line with what I was taught and what I would like to do.
Can you so 2 questions for you. First of all, just maybe explain to us, I take a scan in my clinic, I send it, what's happening? And second question, are we using a library of foot images or foot model to make the orthotics?
Yeah, great question. So, we've talked about the input, how we get that with the scanner. And once you send that to us along with a prescription telling us what you want to do with it, we get the 3D scans and then we digitally modify them to incorporate all the changes you've made in the prescription into the orthotic.
And those changes are because the practitioner asked for it.
Yeah, exactly.
So
exactly. So all of the prescriptive features, if you want to raise or lower the arch, if you want to release some pressure from somewhere, add Morton extension, all of the different things you want to do. When we developed this system, we looked around at all of the software that was out there to be able to do this kind of thing. And we found some that were on the market that allowed us to just about achieve what we wanted to do. But we needed to do post-processing on it. So at the time we were milling molds out of foam on a CNC machine, and we could never quite get what we wanted. So we got 90% there, and then we were sanding them off to adjust them as we wanted. And it was a long process, both in the software and sanding it. The process was long. We got what we wanted. We were never compromising on the quality, but it was a very tortuous path there. So we took a step back and we said, hang on, what we have on the market is not fitting our needs. Let's develop our own. So we spent a lot of time and effort in developing our own software, our own CAD software we call CryoCAD. We run at the lab, and that takes the scans in and modifies them as we want them to be modified to create a Cryos orthotic. Incorporates all the features in there that we want, but more importantly, removes the human error from it. When we're developing all the features that go into making an orthotic, we had to base ourselves on something. So I went out into the lab and I asked all our employees, okay, you're doing this modification, can you do 10 orthotics for me? And I went away and I measured them all, and it was amazing, the range of difference we had. And don't forget, these were acceptable orthotics. We were producing good orthotics that were doing the right thing.
This is what's on the market. All the labs were all the same in that way, where
and
when using
the
people,
staff were very highly trained.
Yeah.
These were staff with 20 years experience, but some of them to thin down the arch to make it a little softer, what we call the corde de blocage, the blocking cord, removing that. Some would remove it down to half the plastic thickness. Some would go down to 0.5 mil. Some would start a centimeter from the edge. Others would start 3 centimeters from the edge. And you can imagine it might sound like a small difference, but when we go and test the stiffness of the orthotics, we developed an apparatus to test the stiffness of the arch, and it was incredible the range we see in the stiffness. The same pair of orthotics made 10 times by one person, not to mention 5 different people. It was incredible. And this was across the whole range of features that are built into the orthotic. So what we did is we set these parameters, lock them in stone in the software. Or when I say lock them in stone, you can always adjust them yourselves in the prescription. But the point being is now we can be very predictable in what we're doing, and so it reduces the range of stiffnesses. It makes it more predictable. So you know that for this patient with this prescription, you're always going to get this orthotic, and that allows you guys the confidence to be able to prescribe what you want.
I remember when we were looking at different scanner or even different CAD software, we did a lot of tests, like took a scan of our foot, send it, and they send back the mold of the orthotic, and it was always not the foot that I have. And even Frederick and I send a scan of our feet, both of our feet, and receive the orthotic. And except for the color, mine was green and Frederick was red, but it was exactly the same orthotic, 3D orthotic. It was nice, but our feet are completely different. So so they're using a library, or they're taking a couple of parameters to make the orthotic.
Yeah, and I think this is a bit of a dirty secret in the industry. Is doing what we have done is very hard. It's very complicated to take the full range of feet. There's a lot of different feet. You see, after working in this industry, you see the whole range. But to develop software that can always create an orthotic with all of the different parameters from the scan input, there's a lot of errors that pop up. A lot of corner cases, a lot of, someone with 4 toes and a huge foot, or, a kid's foot with all the weird and wonderful problems. And a way around that is to use a library. So you can have 20 pre-generated orthotics, and you can shrink it a little bit here and expand it a little bit there, but it's a glorified prefab system. You don't have to manufacture the orthotics in advance. You can just print them, but nevertheless they're not fully custom.
And I think that's the key, right? And I think if we step aside a little bit, we're an industry, you're your business, you want to grow, you have to do more production. The shortage of manpower was a big thing, especially it's still now it's the same, but if we go back even 10 12 years ago, like you said, it has so much dexterity for employee to do that work that when you have one, you want to keep it. But things happen in life and you lose them. How do you do that? You're right. I think this is where prefab and custom kind of became interchangeable, where they say, oh, it's custom. It's not custom. It's prefab. Yeah. But we're gonna custom it to your foot. It's just playing with words, It's a prefab
because your name's written
that's
on the
it.
bottom.
Your
of it,
name
right?
is on it. It kind of follow your arch, but and I think this is, and I have to say with Phil, we had those discussions a lot. Being in the clinic still every day, and I remember, we gave you that challenge, telling Nick, we won't be like the other one. We want to make sure that what we have is going to be a real custom. So and even the right foot is for the right foot, the left was the left. You custom it and you follow, and we want to make sure that the error that can be made on those orthotics going to be made by the practitioner, in a sense that we are responsible when you're in our clinic to take a good scan. After that, the lab must just execute and be able to produce something that we think should fit under the foot.
Yeah, patient. That's it. As a lab, we don't want to make the medical decisions for the patient that you see. We can't do that.
Yeah.
We can't be making stuff up on the fly. And, it is an easy shortcut, and I guess it enables a lot of cost cutting there, but it's really cutting the corner, and it's not producing a fully custom orthotic.
And since Frederick and I are using the orthotic the next week with our patient, it was always a no-go. I mean, you want to cut corner? No, because we want good result with our patient.
Yeah, and that was at the time I might have said differently, but it was a bit of a painful process. But you know what? It was valuable because we couldn't just do anything. We couldn't just do a modification this way and say, well, that's just the easy way and they'll live with it. We'll deal with the consequences later, because you guys were the guinea pigs.
Yeah.
And you saw it, and you were producing doubles, you were doing it saying, no, do me one with the change and one without it, and we'll see the difference. And, after, dozens, hundreds of patients checking that it worked, producing doubles, that's when we swapped. And the whole process was like that. So, it's a long process, but it was the right way to do it.
Well, we needed, like you say, you need the input. So once we got, actually, we got the input, we made sure that the scanner was working well. Then your next challenge of many challenges that you had and you're still having was for you to be able to take the orthotics we were using, the polypropylene orthotics, that we're doing all by hands, to say, now we got a good input, a good 3D foot scan. Now we need to switch to 3D printing.
Yeah.
And that was the second challenge, because we needed something that respected all, the properties of the orthotics. And how did you feel? How did you get there? How did you went from what we had as an orthotics to the 3D printed orthotics? Because yes, you had the input, but now we have to talk about materials. Like you say, we're going from different thickness, resistance to the materials. Is it going to be durable or not, like the other one? So, how do you get there?
Yeah. So the development of the CryoCAD program happened over a period of time where we went from CNC milling out molds. We implemented a robot, 6-axis robot, to cut out molds, which required us to step up our game in the programming department to develop CryoCAD a little more. But once we had the surface that we wanted to create, from the CNC, and we knew the outline that we wanted that the robot was cutting, from there, conceptually, it's simple, in inverted commas, simple, to create what we call a volumized orthotic, or a fully digital orthotic. But that's all well and good for a 3D printer, but the orthotic is more than just the geometry of it. We could imagine the geometry, we could create it on the screen, but what are we going to make it out of? 3D printing at the time, 6-7 years ago, was blossoming. There was all these printers you could get in your garage, printers under $1,000 and then under $500, and we played around with lots of them, but we did not want to compromise on the dynamic properties of the orthotic that we created. The polypropylene material that we were using to thermoform the orthotics had a great dynamic response. It moved with the patient's foot. Yeah. It corrected the patient's foot as they walked, and we wanted to recreate that with the 3D printer. So, trying all the different technologies, we went through hundreds and hundreds of samples to narrow in on the material, but not just the material, all the processing parameters. Okay. So we produced lots of orthotics. We selected the technologies, the type of 3D printer. So it's what we use. It's a SLS printer, selective laser sintering. It's a powder bed process that can create the orthotic from the ground up. It's an additive process, whereas before we were subtractive. We were creating a big sheet of plastic and then cutting it out. With the additive process, it goes in reverse. You only create the material you use. And just as an aside, that's enabled us to reduce our waste by 95%.
Wow.
It's pretty spectacular. We were reviewing things today, actually, in the office, and we used to have 2 big hopper bins outside, enormous dumpsters that were getting emptied once a week, because we had foam boxes and plaster casts and plaster molds and cut off plastic everywhere. And now we have about 5 wheelie bins out the front that get picked up every 2 weeks.
It's incredible.
And we're producing twice as many orthotics. Yeah. So it's we're proud of that. We're proud of that.
Which material do we use for the 3D orthotics? What do you use?
So it's a nylon material.
Okay.
So we were quite hesitant changing material. Unfortunately, at the time, polypropylene wasn't 3D printable, and there's some new stuff out with polypropylene, but it's generally not pure polypropylene, and we've tried it, but we don't get the results that we want, not just yet. I mean, we're always trying new materials, but fortunately the nylon material that we are using, we did a lot of comparisons with the polypropylene, and the stiffness of the material is almost identical. The durability, if anything, is better. So that was one great thing with the polypropylene, is it lasted,
forever.
I mean, it was a bit, let's say, deceptive how long it lasts. They were probably losing a lot of their strength over time. We developed a durability apparatus to test these things. I don't know if you've ever been to IKEA and you've seen the machine pushing on the lounge and over again. Well, we created something quite similar to test the orthotics through millions of steps, a simulated gait cycle that was flexing the orthotic in a similar way that it would flex under your foot. And we measured the stiffness of the arch on these orthotics at the start, after 10 steps, after 100 steps, after 1,000, after 100,000, regularly through the period. And what we found with the polypropylene, the original orthotics, is they were reducing their stiffness about 5 to 10% over about a million steps. A million steps, very roughly about a year of use. What we found with the nylon material is it was increasing in stiffness by roughly 1% throughout that cycle. So the beauty of that is that it maintains its corrective effect throughout the whole cycle. We could then, because the stiffness was very, very similar, the durability was the same, or better rather, we could then basically recreate the orthotics in this material and effectively replace them.
I remember, with the polypropylene orthotic, every year that I see my patient, I need to rebalance them because the orthotic changed shape. And now with the 3D printed orthotic, every year it's almost identical because it was printed in that position. So is it medical grade material?
Yeah, so the material is a USP6 certified, so that's certifies the biocompatibility of the material, so it's safe under your foot. It's a biocompatible material. I think in other industries they use it for surgical implements as well.
Okay.
So very, very inherently safe material.
Can we use different thickness?
Yeah, absolutely. That's the beauty of the 3D printing process. We can control all of the parameters down to the 10 decimal places. That's a bit excessive, but yeah, we try and make it simple for the user. You can we offer a 1/10 of a millimeter increments, but for sure you can write whatever you want in there. And with the digital modification process, if you want to say reduce the arch by 3 millimeters, it's exactly 3 millimeters. It's not 1.5 or 3.8, it's 3.000 millimeters, the way we can modify it.
I remember when you were doing testing on the polypropylene orthotic, you were measuring the thickness of the orthotic, and the thickness of the orthotic was all over the place since you stretch the polypropylene on the mold. So it was like 2.7, 2.4, 3 millimeter. And now with 3D printed, it's like all the same thickness everywhere.
Yeah, we maintain control of it at every point. So with the polypropylene, with the manual process, you kind of lose control over that. It is what it is. There's not really much you can do about it. It's kind of inherent there. But with 3D printing, 3D design, we control every aspect of it.
Yeah, with once we were with the polypropylene, there was like 2 millimeter, 3 millimeter, 3.2 millimeter, but that was it.
We were stuck with what we could buy, right? We had to buy the sheets 1 year in advance. As a manufacturing company, that's a tough pill to swallow. And because of that, we had to limit the thicknesses available. And I remember when we started this, he said, "Hey, I want to try 2.5 mils."
Yeah.
And I'm sure if I pull up the statistics, that's probably the majority of what you order now. And that was just something we could not offer before.
And I think, and like you said, because the material keep all its properties through the time, it doesn't lose its stiffness, even gain a little bit, maybe 1%. You know that even if you use thinner material, it follows the shape of the foot, you're able to have the same result. which is important for the patient. It's important for us as practitioner because then the patient is going to be able to wear it in most of their shoes. It's going to fit in their skates, ski boots. So you don't have now, it's giving us more tools to have patient be more compliant, being able to wear it even more than before. And then if you do that, like we always say, orthotic is a treatment. We're using orthotics to help the patient. You have different pathologies, different mechanical problem. So when we're able to play with the thickness, we're able to really customize. We go back to this again. We customize it, and then what's interesting that you can go from people, if when you treat kids, children that need orthotics, you can start with thinner material because the foot is smaller, there's less weight, and then you can just gradually over time, when they still need it, just increase the thickness if you need to. So it's a big plus. So this is one of the things where we switched materials, not because the materials wasn't good, just because we tried to find something even better, which is a nice thing about it.
But the whole process too, now that we've implemented it and it's up and running, it opens up the design choices that we have for the orthotic as well. Something that was always done is the posting, the rear foot posting. So the traditional manufacturing process, that was a block of foam that was glued on and then ground off by the people in the lab. It was shaped, and just through the process, it's a very sort of orthogonal shape. There's very sharp corners, and it's very square, and also the material it's made of. Making it out of that EVA foam, that material compresses after a couple of months, a year or so, and then you've got to rip it off and do it again. But with the 3D design process and 3D printing, we can incorporate that directly into the orthotic. So we've developed this intrinsic posting where, just as you could do before, you could do different thicknesses, different areas, and make it a more smooth flowing shape, which fits better in the shoe.
Yeah. And I mean, with the regular EVA, I mean, you need to change the posting almost every year. Yeah. I mean, now it's there, and it's
not going to change.
Yeah.
I mean, imagine what that does to the patient, right? If you've got to change that every year, and you change it every year because they come back roughly every year, but between the time you've given it to them and that 12-month appointment, it's been compressing and compressing and compressing. So that treatment,
you're changing the treatment.
Yeah, that treatment that you prescribed is just getting less and less and less and less over time. Yeah. It's
one thing that I found out with the 3D printed orthotic is, since the shape is perfect with the foot, the pressure on the foot is very equal. So I don't need to use much top cover anymore, because before the top cover was kind of hiding the inaccuracy of the shape of the orthotic with the patient foot. Now the orthotic is exactly the patient foot, so the patient, even if there's no top cover, feel great, but because the pressure is equal everywhere.
Yeah, and that's what a great way to hide all the inaccurate processes, by just sticking a big soft layer on the top. What does the soft layer do? It conforms to the patient's foot, and that's exactly what we've done with the Cryoscan 3D. That pillow, the membrane, captures the shape of the foot. It captures it accurately, and our accurate process allows us to recreate that. So it sounds a bit scary for some people. I'm going to put this hard thing in my shoe, it's not going to be comfortable. But if they're forgetting that it's made 100% custom to them, and with the accurate process, it fits them perfectly.
Yeah. And another point of fit perfect. I mean, before I was always reducing the width of the orthotic, adjusting the orthotic to fit in the shoes of the patient, because again, it was so much manual process. Now we print the orthotic, it's exactly the width of the patient foot, it fit perfectly in the shoe, and I don't do any of those manual change on the orthotic. It's the game changer for when you deliver the orthotic to the patient.
Well, that's it. Because of the repeatable process, you can be much more confident in what you order. You wouldn't have to order larger knowing you'd have to trim it back maybe. It comes out just as you've ordered it. So we've had clinics that have become much more efficient. They didn't need to employ staff to modify orthotics all the time. High volume clinics that are ordering thousands of pairs a year that would have to have orthotists on staff to modify orthotics. They don't need that anymore because they know what they order is what they're going to get, and it's going to fit the patient.
Yeah. Well,
How long does the orthotics last as long as the polypropylene, you would say?
Yeah, it's the orthotic itself lasts at least 2 to 3 years. Okay. What we find throughout that process, though, is the patient's foot is going to change. It's going to adapt to the orthotic. So is the geometry of the orthotic, the prescription that you've prescribed, still valid after 3 years? That's the medical decision that you guys have to make. But the orthotic itself is still a very functional product.
So you would
after
say
2
usually
years.
in the fourth year, this is maybe you're going to start to lose some of that, properties.
Yeah,
that
after
then
4 years, it really starts to, it's tough to test out that sort of time frame in there. So, we stand behind it on that. But, 4 years is really getting into the end of life of the product. But, that's the medical decision that the user has to take. But it really changes the picture when you compare it to the EVA orthotics that are, probably more of an accommodative thing that, they compress out and they lose any corrective effect that could have been there after 12 months. With these, the patient can put them in any shoe and wear them for longer and still maintain that orthotic treatment that you prescribed.
Yeah. Let's just go back a bit about you talk about the 3D printer. So what kind of printer? I mean, how big is the printer? Is it like a small printer? And how do you test the quality of what you're printing out?
Yeah, so the type of printer we use, it's an SLS printer, selective laser sintering, and they're real production machines. These are not the ones you put in your garage at $300. They're real production end use part printers.
How big is that?
They're pretty big. It's about 3 meters by about 2 meters.
Wow.
And about 2 meters deep, and they're a pretty serious piece of kit, and they take a fair bit to operate, but the process is reliable and repeatable. And once we have the volume as a lab to be able to run these machines, it's quite incredible. We as a lab, we'd always been saying no to clients because we just couldn't produce the orthotics.
Yeah.
The training process to train someone to modify the biofoams or cut the plastic was just too long. Now with the 3D printing process, to scale up, we add another printer, we buy some scanners, and the process is much shorter. So we can get the orthotics in the hands of people who need them sooner.
But you talk about the property of the material, that it was very important. So
so the printing process itself in SLS, it's kind of like it's a batch process. So we can print a whole batch of orthotics at a time, and it's essentially in an oven. But there's dozens of parameters that go into making a successful build, and we spend a long time narrowing in on what works and what doesn't, and essentially developing our recipe for it. Nevertheless, being a batch process, if something goes wrong in that build, we need to know about it ASAP. Yeah. So we've developed a very intricate quality control process. We print test parts throughout the build. We test them every build so that we know that the parts that are printed within that build fit within our parameters. Okay. It does us no good to have done all that testing up front and just let it all drift off into the distance because, we didn't realize that the oven was getting a bit cooler, or, we didn't realize the laser was losing power in the 3D printer. So having control over all that enables us to really hit those quality control measures that we're looking for. And it happens that we print a build and, we've got to throw out 100 pairs of orthotics.
Right.
But we do that because we don't want to deliver junk to our podiatrists.
Because there's a more than that, but there's the shape of the orthotic.
Mm-hmm.
We say, well, that's kind of easy to get, but then the property can be very different, even if the shape is correct.
No, exactly. I mean, we can print the orthotic, and it can be end up with the consistency of rubber. It's just flexible and really soft. I mean, that's not going to help your patient.
Yeah,
it might look nice.
Yeah,
but I mean, it's in your shoe. It doesn't matter if it looks nice if it doesn't do what you need it to do, right? So and that's I guess you guys have kept us honest on that, right? The podiatrist, you guys using it, making sure that our quality control is very, very tight, and that we throw out those parts that aren't working. And maybe that means that pair might take an extra day to get to your clinic, but generally we see that you would rather wait another day to get it into your patient's shoe than get something that doesn't work.
Right. And there's different color?
Yeah. So the material we print in is white. It's a powder, so it comes out white. But we can color it. So we've developed a number of colors. We have blue, black, pink, tan, and of course we can produce white as well. It's quite a process to do the coloring, because it does change the properties of the plastic, and we want to make sure that they are within the range that we need. So we are working on developing new colors, but we want to make sure that number one, we keep the properties, we keep the dynamic properties of the orthotic, and we want to hit some consistent color levels too. So we don't like having a huge range of stuff we put out. So it's an interesting option, because before with the polypropylene we had beige.
Yeah.
I mean, we chose the beige, but the beige was popular, but there was no room to change the color.
And this is why we added some materials to make some color on it, but just changes once again, the intrinsic properties of the orthotic. So you don't want that. You want it to be what it is. Yeah,
and we also have a range of designs, of patterns we can put on top that make it a little more attractive to kids. We can put music notes or soccer balls, or different designs on there.
I would even say that adults love them too.
Yeah. I mean, I have a nice abstract pattern on the bottom of mine, and it does that, takes that little bit step above to make it a little more attractive to the user, the patient.
So what would be your next the next step in our orthotics production? Orthotics 3D printing. What do you think we should be able to do in the future?
Yeah, well, we are, as we expand, we're looking to add printers to the line, and we're certainly looking at lots of different materials on the market right now. There's been lots of development. I mean, this is a new field, right? So there's lots of stuff developing, new materials coming out all the time. We're keeping an eye on that and seeing what we can make use of and everything. But the material we have right now is very good. We're looking at how we can make those top covers a little easier, a little more repeatable. We still produce the top covers. We find the vast majority don't need them, but there are some patients that do, and so we do still produce them. So we're looking to make them more productive and make them at a higher quality.
Okay. Oh, thank you, Nick. That was really informative, and I think using the orthotics in our office, we do see the value of it. I would never go back to the polypropylene, and I loved it. I've been doing this did it for more than 20 years, and it was great. But now having what we are expecting when we see a patient's foot, knowing that I'm going to treat that patient using that type of orthotics, and knowing that when it's going to come back in my office and I'm going to be able to fit it in their shoes under their foot, it's such a great value, and it's so important to increase the success of my orthotic treatment. So I think that 3D orthotics, it's a major it's a game changer in the orthotics world. And if it's used properly with the right, like you explained, all the right parameters, either with the 3D scanner, then the material itself, I think we're really getting where we want to be. And I'm sure we'll keep you busy to bring us some new features to those orthotics for sure.
For the past 6 years, we've been, well, more than 6 years now that we've been doing 3D printing orthotic. The patient loved it. The health professional love it. It's really a big game changer, like Frederick said. And thanks to you, it went very well. And a lot of other projects are coming in the future.
Yeah, no, I look forward to the challenge. And thanks for having me on.
Thank you very much.
So if you want to know a bit more about the orthotic, the CryoScan 3D, you can go on the website and see more. There's video too, and always welcome to communicate with us. And the other podcasts are very interesting to know about the history of cryos and the other technology. So see you next time.
Thank you.
Thank you, Nick.
Thank you.